Understanding basic electrical components and circuit connections. Welcome to our video on basic electrical components and circuit connections. In the next 5 minutes, we'll explore key electrical symbols, the differences between cells and batteries, and how different circuit connections impact the overall voltage. Let's dive in. Let's start by looking at some common electrical symbols used in circuit diagrams. This is a resistor, represented by a zigzag line. It resists the flow of current. Next, we have a capacitor, shown as two parallel lines, which stores electrical energy. The battery symbol, typically shown as a pair of lines with one longer than the other, represents a power source. Finally, the switch, depicted by a break in a line, is used to open or close a circuit. Now, let's clarify the difference between a cell and a battery. A cell is a single electrochemical unit that generates a specific voltage. When you connect multiple cells together, you form a battery, which can provide a higher voltage or more energy capacity. For example, a common AA battery is technically a single cell, while a car battery contains several cells connected in series. In a series connection, cells are connected end-to-end, positive to negative. This increases the total voltage of the circuit. For example, if you connect two 1.5 volt cells in series, the total voltage becomes 3 volts. The current remains the same as that of a single cell, but the voltage adds up. In a parallel connection, all positive terminals are connected together, and all negative terminals are connected together. This configuration keeps the voltage the same as a single cell, but increases the total current capacity. For instance, two 1.5 volt cells in parallel still provide 1.5 volts, but can deliver twice the current. Combining series and parallel connections allows you to balance voltage and current. In this setup, some cells are connected in series to increase voltage, while others are connected in parallel to increase current. This approach is commonly used in applications where both high voltage and high current are needed. Let's calculate the total voltage in a series connection. If we have two cells with the same polarity, say both are 1.5 volts, the total voltage is simply the sum. 1.5 volts plus 1.5 volts equals 3 volts. But if one cell is reversed, the voltages subtract from each other. So 1.5 volts minus 1.5 volts would result in 0 volts. To recap, we've explored common electrical symbols, the difference between cells and batteries, and how different connections affect circuit voltage. Understanding these basics is crucial for designing effective circuits. Thanks for watching, and don't forget to experiment with these concepts in your own projects.